Hello guys, and today I'm going to show you how to define massFlowRate boundary condition in OpenFOAM. You might have a problem like I did. I am very big noob in OpenFOAM. I mean, I'm not that big of a noob, but and this is documentation for this boundary condition. Actually, with this boundary condition you can define volumetric flow rate or mass flow rate. So these are example how to define volumetric flow rate and the mass flow rate. So there are definitions about this settings somewhere over here, but I am very lazy, and as I said, I am noob in OpenFOAM, so I didn't read this and I don't understand any of this, especially these graphs. So what I realized, I had a very big problem with density. So when I get calculations, I get very big numbers of velocity field, like 200 meters per second, but in reality I need to get like 1 meter per second velocity field. So maybe you are also getting the same problem. So when I give it volumetric flow rate boundary condition, I get 1 meter per second velocity, so that's good. So the problem is I get unrealistic velocity field with mass flow rate boundary condition. And long story short, you have to change this from rho is to rho equals something, like literally anything you define it to. And if you do it like this, you must define this rho inlet. This is density at your inlet boundary condition. So this will not be a problem if this is something random, because it will use this value. So if you set up your boundary like this, you are good to go and you will be fine. So if you want to know a little bit deeper what is happening over here, I can show you, because I was debugging this problem. So first of all, let me say what is this extrapolate profile. This is I'm not exactly sure what this is, but from my observation, if this is set to true or yes, this gives a vector like velocity, and if it's set to false, it gives scalar value. In default value, this is set to false, so my velocity is calculated as scalar value. This is the thing I've deleted in my debugging process, so everything else I'm going to show you. So let me see what's the problem. If I put boundary conditions like there is in the website, like this, what do I get? So before I start, let me clarify one thing. If you want to know how this code works, this boundary condition does something, and it is defined somewhere to do something. And in the website, we can see it is defined document generated in this. So this is some header file, I don't know what this exactly is, and this is the file that has its functions that calculates our inlet velocity. If we enter files that that ends with H, we get something similar that looks like this website, and this C file is the file we need. So these are constructors, and with our boundary conditions, this constructor is the one that executes. So these are default values that constructor needs, and these are basically things that we define in this U file. And after that, there are some values that the constructor passes, so it can calculate with these methods down here velocity. So you can, as you can see, this is there is row name. These are some values that are imported for debugging. So also row inlet is important, flow rate is important for debugging, and so on, so on. So this code over here executes, and it calls some functions down here. So if this extrapolate profile is true, this part of method will execute. But by default this is false. So as I've said in the beginning, we need scalar field for velocity. So this will be false and this will execute. So this is the formula that shows us how velocity on inlet will be calculated. And this is sum of density times every single cell. So this is how ChatGPT described it. This is flow rate over time. I doubt that it is over time, but okay. And this is sum of all areas on inlet times density. And this is basically how velocity is calculated. So now that you know how velocity is calculated on this patch or boundary condition, now we will do some printing or debugging. So when I start my solver, it will initiate this code, initiate this object. First, this code runs. This is the constructor. As you can see, constructor runs first of everything. This is where solver initiates, blah blah blah, and first of all constructor runs, and he does something, blah blah blah, and now this part of code runs. This is some other method that needs to be updated. We don't care about this right now. He initiates his constructor over here, and now it goes over here and prints this row and prints this row type. This is what we need. He comes over here, and the thing is that this row that is being updated is all actually calculated. This is what we don't want. I mean, you want it if you are simulating incompressible flow, but if you are simulating compressible flow, you don't want it. And you also don't want it because this is actually wrong. Why is wrong? Because he uses this value from this file. And where do I see this? So he updates value with this type. This is over here. So he updates it over here. So what can we see here? We can see that type of row is not the row that we actually defined over here in U. This is not our row. So as I've already said, this is area times density, and this is flow rate. This is I guess this is normal, and this is flow rate that we defined over here. So maybe you're thinking, wait a little, this is good and this is good. So what's the problem? This is also good. This is my average velocity that I'm expecting. So what's the problem? So if we go down a bit further, this is first iteration. and he's trying to update here some things, but it doesn't matter because it doesn't need to be updated. So basically, if we go down to the second iteration, this is second iteration, and we see solving for a row. This is also calculated still, and now our sum of row and area is large much more smaller. Why is this? My assumption is because this is some default value for some guess, and because this type is calculated, you see uniform 2. So basically he calculated density that is a number of 2, and for every other iteration it is number 2. Before I was testing this, sometimes this was 2, sometimes it was 3, blah blah blah, and I always get this velocity wrong. So you fix it by not giving him over here a density for this, because we don't want calculated row, we want fixed value row, because we are simulating incompressible flow in my case. So I basically type here like row inlet, or you can basically type whatever you want. I save it and I start my calculation once again, and now you can see type row is not anymore some default value, it is D. I don't know what does it mean. And we can see my inlet area is good, and my velocity is good, and my mass flow rate is as defined here. If we come here to first iteration, we can also see the same thing, and if we come here to second iteration, we can see the same thing. I don't know if I don't know to read this OpenFOAM documentation, but yeah, in this density field name, it is not this. Don't change. Don't think that this thing is this, because it is not. I'll show you. So if we use this row A here, and if we comment this, we should get this value, right? So yeah, we didn't get because we didn't define. So it didn't find density field row A for some reason. So maybe I didn't define this right, I don't know. And even if I try to ask ChatGPT, I think it won't give me the right answer. Yeah, it is giving me the thing I already have. So let's see, if we do this, I don't think it's gonna change anything. Yeah. So yeah, now you see ChatGPT is telling me I don't need to use row at all. So let's see what happens if I don't use a row at all. I'll tell you, this is also wrong because I've tried it, but it is wrong because if we look at documentation, we see default value for a row is actually row. So it is the same thing that if we do this, it's the same thing. So basically we'll have again the same problem. We get default row value, so this thing will be ignored. So we actually must define this, and we must define this, and just change this value to something random. So now it will work. As you can see, it is working. So thank you and bye bye.